there's a focus on ensuring that those populations have environmental justice, have reduced risk of exposure, and that we're considering them in our design of studies. Now, the reason I asterisked the older adults and the pregnant people and children and adolescents is because they actually, of course, that's all dealing with age, and age falls on a spectrum. And there's something called the developmental origins of health and disease theory. It's also, once upon a time, the original person who developed this theory, his last name was Barker, and it's also been referred to as Barker's hypothesis. So it basically says that exposures that we receive early in life, and that can be defined in different ways, whether it's prenatal, so in utero, or whether that is something that happens during the childhood, early childhood, middle childhood, late childhood, adolescence, whether it's multiple exposures, chronic exposure, one-time exposure, that those exposures are going to affect us throughout life. So adult onset health outcomes may be, depending again on the exposures, may be associated with an exposure that happens early in life, and then you carry it through your life. And there's another sort of off-the-cuff type way of referring to it as cradle to grave. So it would be wonderful. They're very expensive if they exist, the few that may exist. A longitudinal study that follows a cohort from birth until death. That is perhaps an ideal in the situation of DOHAD, because you'd be able to see what happens when they're in utero, all the way through childhood, all the way through early adulthood, middle adulthood, and late adulthood, and see what exposures actually do matter in populations. And so a few resources for you in terms of current research. There's child health and development studies that I'm going to be referring to actually a little bit later on. There's the Dutch Hunger Winter Study, which is a famous, well-known study in epidemiology that looked at children, Dutch children during World War II, there was a famine and the health effects, and they followed those children throughout time. The Framingham Heart Study is another excellent resource to think about for older adult outcomes, and they've started thinking about exposures. And then also the Atomic Bomb Survivors Lifespan Study, which, as I mentioned, radiation is a consideration, and how that may have happened early in life, and then what happens as you get older. So I've now introduced you to at-risk populations. I've introduced you to the idea of the age spectrum from young to old. But what about exposures later in life? So just as a introduction, life expectancy at birth and age 65 by sex in the United States. So I'm focusing on the United States in this framework. And so we know that in general, life expectancy is into the late 70s in the United States. Depends on, there's a sex difference between men and women, between males and females, of approximately the late 70s for males and the early 80s for females. And so we have to think about, what does it mean to be exposed later in life? And what does it mean for quality of life and for health outcomes, especially by the time that an individual hits their 70s or 80s, they probably are carrying with them some health outcome already. And do exposures later in life have an impact? Are they carrying with them exposures from early in life? How does it all come together, and what does it mean? And I often say the study of environmental health is very young. It's really since about the 70s that we've been studying environmental health and really focusing on the environment, ever since especially the EPA came to be in the early 70s. So we're still learning. We're still trying to figure out exactly what it means to be exposed at different points in life. We also want to think about the population pyramid. This is something that in public health is very helpful when you're thinking about a country or a city. What does that population look like in terms of age spectrum? And so for the entire United States, this is what the population pyramid looks like. It's a pretty stable population because although our base is getting a little bit smaller, we'll see what happens over time. But as would be expected, with longer life expectancy, we're having more people up at the top of the pyramid, more people that are hitting the age range of the 90s into 100. And so what about that tip of the pyramid? How do we help people in terms of environmental exposures at the top of the pyramid, which is continuing to grow? And we see that in this chart, population by age group is growing, right? So we have those middle adults into later adulthood, 25 to 64, continues to grow. And just above it, the 65 plus year olds are also continuing to grow. So there's a renewed focus in environmental health shifting towards the older population. In 2012, the WHO Director General made a big statement at the Gerontology Congress. She said, being in the older age group is becoming the new normal for the world's population. Our seniors are now our biggest age group. And within the next 5 years, so she was predicting from 2012 to 2017, for the first time in history, the number of adults aged 65 and older will outnumber children under the age of 5. So we are starting to see a shift worldwide, potentially in those population pyramids that I just showed you for the US. So we know an already at-risk population for environmental exposures is growing on a global scale. And we really have to think about not just what their exposures were early in childhood, but also how are we helping those people? What is going on in the built environment? Because the built environment is part of environmental health. How are we ensuring that their health is taken care of and that outcomes aren't made worse or new outcomes don't develop? For instance, with the built environment, are spaces and pathways available that encourage older people to keep fit and active? This is an important question in clinical care too. It's a great question to ask older adults when they come in for care. What is your environment like? And to think about whether or not something can be done in terms of facilities. Are there accommodations and modifications that can be made to facilitate and encourage exercise? And also, is there something about their housing? Because that's where people tend to spend a lot of their time that will compensate for declining functional capability. So reduction in physical capability. Are there ways that we can accommodate the built environment or change the built environment to make it easier for mobility, like traffic lights being timed specifically so that older adults can get around easier? So while we know that exposures can be chronic over the lifetime, they may start in utero, they may start in early childhood, they may start later in life. We also are thinking about mixtures of those exposures. Are they old mixtures, new mixtures? There's new chemicals that are put out onto market every day, at least in the United States. So there are older exposures that have to be considered from when an older adult was young versus new exposures that may be coming about today as new chemicals are developed. Temporality can be very difficult to discern in older adults. Unless you've been following an older adult, unless an older adult has been extremely cognizant of what they've been exposed to over their lifetime, it's very difficult to determine at what point an exposure may have occurred. And then what else can we do to modify risk factors? Well, health education. And so that's also part of what I would propose could be introduced into clinical care in terms of older adults, to definitely provide education about their environment so that they can also have some responsibility and be sure that they're taking care of their environment for themselves. So I said that I'd be talking about a few exposures, and so these are the ones that I'll be focusing on in terms of modifiable risk factors for age-related diseases. So there's heat stress, extreme weather events, or as I mentioned already, climate change, climate crisis, climate emergency. The list goes on for the ways that we can talk about climate change. lead, the chemical lead, bisphenol A, which is in plastic, and air pollution, which is another big topic, but I'll be narrowing it down for us. So thinking first about heat stress and extreme weather events, it is actually not only an emerging area of study over the past 20 years, there's been more of a ramp up of studying this. It's also an emerging area of study in older adults and thinking about what happens when there's heat stress and extreme weather events. Urban heat islands are something to think about, especially in our population of older adults where we have to think about what is their access to cooling centers, what is their access to air conditioning, how do they remain cool. Dilapidated housing is also an issue when we think about not just heat stress and insulation, but also extreme weather events and whether or not an extreme weather event like a hurricane or a tornado would affect their ability to not have a negative health outcome from an extreme weather event and whether they are protected in their housing. So infrastructure considerations, much like housing, when you have flooding, what happens to mobility? Older adults are less mobile in general, and how can they get around once an extreme weather event has occurred? If there's transportation access issues, that's an environmental exposure. I mentioned access to cooling centers, and then also when there's an extreme weather event, there could be a problem with access to food. An individual may already live in a food desert, but then if there's a problem in terms of climate change where there's short-term access to food availability, how do we solve that problem? Lead has been around for a long time, and there's been a variety of regulation with lead that has tried to reduce exposures to lead. However, when we're thinking about an older population, we know that the regulations that have been put in the 1970s and beyond in terms of lead would not necessarily make a difference to exposures that an older population may have had in younger life. So another issue with lead is that it is stored in bones. So if you are exposed to lead, it will deposit in bones. It will also be excreted, but it will have approximately 20 to 30 years half-life in your bones. And in adults, approximately 80 to 95% of retained lead is kept in the bones. It eventually will come out, but exposures will remain in the body. Lead in your bones will increase with age, so this is true of everybody, and it's known that by age 70, more than 1/3 of bone mass will contain lead that was acquired early in life. So remember, there are regulations that have come about that are protecting younger people and everybody really these days, but once upon a time, there was no regulation. There was lead in paint, there was lead in gasoline, and there was exposure to those areas for lead. Bisphenol A, or BPA, is a common plasticizer. It's found in plastic, and its production also predates a lot of regulation that we have now for some chemicals, including BPA. The production began in the 1950s, so right after World War II, plastic became one of the new wonderful products that was actually, BPA was discovered to be a plasticizer both in the United States and in Germany in 2 different companies, and there was just a proliferation of plastic products after the 1950s. BPA has a very short half-life, so unlike lead, it has a short half-life of about 4 hours. It's easily excreted. But the problem is, great, it can leave the body, but there's ubiquitous exposure. We're exposed to it every day, all day, from a variety of products and sources. Diet is considered the main route of exposure for BPA because of food contact. In our plastic serving utensils and serviceware and linings and cans and other food containers. There's also some replacements that have come onto the market. There's BPS and BPF. However, they're even less studied than BPA. And they're very similar in structure to BPA. And there's a continued growth of global demand for plastic, which will include BPA. Air pollution, again, a big topic, but to boil it down, so there's stationary sources and mobile sources of air pollution. I mentioned smokestacks earlier. I'd mentioned airplanes and cars earlier. So we can think about all the different ways that there's pollution that can get into the air, but there's also not just things that we make, that humans make, anthropogenic sources. There's, of course, natural sources. So there would be air pollution, what we might consider air pollution no matter what in the world, volcanoes and sandstorms and a variety of other naturally occurring events that would create air pollution that would be of concern. But we have added to that mix. ETS, or environmental tobacco smoke, I mentioned earlier, inhaling environmental exposures, and so cigarettes are one way, of course, but there's other ways of smoking tobacco. There's other methods besides cigarettes. And there's a number of pollutants that fall into the air pollution category. PAHs, or polycyclic aromatic hydrocarbons, heavy metals are in the air, particulate matter. So that's basically just the size of a pollutant that can get into the lungs. And it can be a variety of things if it's not a specific chemical. Black carbon, ozone, sulfur dioxide, and nitrogen dioxide are common air pollutants that are studied at a large level. And then built environment and how we use the land, those can be other factors related to air pollution. Just think about next time you see a roadway being paved with asphalt. That's built environment, that's land use, and that's air pollution.